All right, welcome to the remix of this lesson right here. So I wanted to bring this up because Eureka wanted us to find the unit rate a slightly different way. So when I found the unit rate in the first video, what I did was I divided the number of ounces by the cost, and we got an answer of 2.5 ounces per dollar, meaning that for every dollar we spend, we get 2.5 ounces. And what Eureka was looking at was it wanted us to find the amount of dollars it costs per ounce. And the way we do that, we would just invert this. So instead of dividing 12.5, which got us 2.5, we divide 5 by 12.5 to get us 0.40. And what this would mean when we divided the cost, or we divided the cost by the number of ounces, what we get is a unit rate of unit rate per ounce. So here instead it would be 0.4 dollars per 1 ounce. So they're both unit rates, just they work differently, right? They actually, I mean, they work the same, but they it's a different way of thinking about it. So instead of when we went up right here, we multiplied by 2.5. Well, we can also instead we could come up and divide by 0.4 to get up here, right? And it makes a little bit more sense if we consider like the cousin problem that we had last time, where he spent $10, right? So he spent he spent $10. So we would divide that by 40 cents. No, what I'm trying to say is, what if he had bought 10 ounces? So going back to the cousin problem, if cousin Quentin here got 40 ounces worth of frozen yogurt, we can multiply 40 ounces times 0.40 to get us a cost of, I forgot what it was, 40 times 0.4. Yeah, Quentin spent 60. Man, he spent a lot of money on that frozen yogurt. That's really not too outrageous for that much yogurt, I guess. I don't know. I don't know the standard rate for yogurt, but so instead of dividing by 2.5, we can multiply by 0.4. And what we actually have here, these two things are multiplicative inverses. And that's one of your vocabulary words, multiplicative inverse. Multiplicative inverse, which is known as a reciprocal. And you'll remember from 6th grade, we talked about reciprocal being just a fraction flippy-floppied, right? So we flippy-floppied these guys. So instead of the 5 being on top, 12 is on top, and vice versa. Those are reciprocal values. But either way you think about it, you would have thought about it would have been right. It's true. Both of these things are true. It is both 40 cents per ounce, and you can get 2.5 ounces for every dollar. So I hope that was perfectly confusing. Let's move on. Go down to example 3 now. So I skipped this in the first video, mostly because it's been kind of long. I'm not sure if we'll get to this one in class. It's a pretty decent problem, but let's look at it together now. So Alex spent the summer helping out his family's business. Great. He was hoping to earn enough money to buy a $220 gaming system. I don't know what gaming system he's buying for that much. Halfway through the summer, after working for 4 weeks, 4 weeks, for 4 weeks. Okay, so halfway through the summer, he worked 4 weeks, and he had earned $112. So great, my math brain's already going off. I see some numbers here that I can work with. Great. Alex wonders to himself, if I continue to work and earn money at this rate, will I have enough money to buy the gaming system by the end of the summer? Ha ha! To determine if he will have enough money, he decided to make a table. So he started a table down here, okay? He entered his total money earned at the end of week 1 and his total money earned at the end of week 4. Fantastic. Okay, so you can see Alex already started marking down the monies that he made. He made $28 in his first week, and by week 4, this is cumulative, he had earned a total of $112. Okay. So we're going to work with a partner to answer Alex's questions, right? You look like an awesome partner. Let's work together, right? So what is Alex's problem? Is he going to have enough money to afford the system by the end of the summer, right? So he's got 4 more weeks of summer to go. So we need to figure out if he's going to be on pace to buy that gaming system. So why don't you take a minute with your partner and or independently and see if you can come up with an answer. Is he going to have enough money, or is he not? Show your work. All right, so those are some very interesting answers. I actually want to come to part B first. Are Alex Total's earnings proportional to the number of weeks he worked? This is a fair question, right? We know that in his first week, he made $28. So is he making the same amount each week? Well, if he is, then week 4, $112. Let's multiply. He worked 4 times as many weeks, right? So we should be able to take 28 and do the same thing with it, multiply times 4, since he worked 4 more weeks. And let's see if those two ratios are proportional. 28 times 4. So far, check. Alex's earnings are proportional, right? And we only have these two to work with. So based on that, we can assume that, yeah, Alex's earnings is proportional. So yes, it is proportional. I'm just going to write a little yes right here. Right now, we'll come back down and we'll answer that problem more thoroughly. How do you know? You look up there. Okay, great. But the question still remains: is he gonna have enough money by the end of the 8th week, the end of the summer, right? So we should be able to multiply 1 times 8, since every week he's going to be making $8, right? So every week he makes $28. So let's just check. We need to multiply 28 times 8. Let's do that. 28 times 8, 224. So on the 8th week, you're going to have $224. All right. So is that enough? Is $224 enough money? Yes. Yes, it is. Fantastic. Okay, because you can see 224 is bigger than 220. You're going to have enough money, right? All right. If you hadn't already, I want you to go ahead and finish filling out this chart, and I will be back with a completed version of this example. Get to work. All right, so here you go. This is a completed version of the chart right here. You can take a look and check your work. And this is just one version of what a completed answer for this may look like. Remember, just check your rubric. Express complete thoughts. My answer was, by the end of the summer, Alex will have earned $224, which is more than enough to purchase the gaming system. And you can see I was being a little sarcastic down here. Oh, but wait, taxes. Because if you include taxes, you probably didn't have enough. But if we're just assuming that there's no taxes in this scenario, right? But if you said no because there are taxes, then I'd also give you credit, right? All right, so part B, are Alex total earnings proportional? Yes, and we know this because 1 and 228 is equivalent to 4 and 112, right? So what I put was based on the information Alex provided. I believe Alex will earn a constant rate of a constant $28 per week because of the information he provided. But just for the sake of argument, I mean, Alex only provided us with these two pieces of information. So hypothetically, he could have earned something totally different in weeks 2 and 3, and it's just a coincidence that weeks 1 and 4 happen to be proportional. But again, we don't know that. We're gonna assume that he's earning $28. That at least that's my prediction based on what we know, right? All right. Thank you for this for your time. Again, you've been assigned the exit ticket and the problem set in your workbook. Remember to check your rubric for how to respond. Great. I'll see you all in the next video.